Could our universe be just one chapter in an endless cosmic saga? A groundbreaking discovery by the James Webb Space Telescope is turning everything we thought we knew about the universe upside down. Astronomers have spotted a distant galaxy so unusual, it's challenging the very foundations of how we believe the cosmos began. Instead of supporting the familiar Big Bang narrative, these findings are pushing scientists to consider something far more mysterious, that our universe may have evolved in a way we've never imagined. Among the pioneers of this idea is Sir Roger Penrose, a Nobel laureate who argues that the universe moves in infinite cycles of death and renewal. Even more astonishing, he claims to have uncovered evidence that remnants from a previous universe might still be lingering in our own skies. In today's journey through space, we'll unravel what Webb has revealed and explore the tantalizing possibility that some celestial objects are ancient relics from a universe that came before ours. When Webb directed its powerful eye near the Big Dipper, it picked up faint, enigmatic lights that had been racing across space for over 13 billion years. These glimmers belonged to objects born just 500 million years after the Big Bang, and yet they were already enormous, rivaling the size of the Milky Way. Such rapid growth shouldn't have been possible, and now scientists are left wondering, have we misunderstood the universe's true origins all along? That simply shouldn't be possible. According to our current models, there just wasn't enough ordinary matter in the early universe to build such massive galactic giants. Yet here they are, so strange and powerful that astronomers have nicknamed them universe breakers. These mysterious structures have thrown a massive wrench into the gears of modern cosmology. And the surprises didn't stop there. Not long after, the James Webb Space Telescope uncovered even more galaxies, each one far too rich in stars for its young age, just a few 100 million years post-Big Bang. But Webb didn't just challenge our ideas about galactic growth. It also delivered a blow to another cornerstone of cosmology, the expansion of the universe itself. Scientists have long relied on the Hubble constant to describe how fast the universe is stretching. On paper, theory predicts a rate of 67 kilometers per second per megaparsec. But when we actually measure it using supernovae, red giants, gravitational lenses, and pulsating stars, the number jumps to 73 kilometers per second per megaparsec. Now, with Webb's latest findings, this cosmic mismatch has only been confirmed and deepened. The question looms larger than ever: why doesn't theory match reality? Some researchers are proposing a radical, mind-bending answer. Our universe may be colliding and merging with other universes. What if the early phase of inflation, the blisteringly fast expansion after the Big Bang, wasn't just a random burst of growth? What if it was triggered by our newborn universe being absorbed into a much larger parent cosmos? To explore this idea, scientists have created new mathematical models to predict what happens when multiple universes interact. The theory suggests that such interactions would effectively expand the volume of our universe, and what we perceive as expansion might actually be the stretching and merging of cosmic domains. In other words, the universe we see may be just a small part of a far bigger, interconnected multiverse, and Webb might be offering us the first clues. As scientists pushed their models further, they made a stunning discovery. When they calculated how fast the universe should expand under this multiverse merging scenario, they found something unexpected. The numbers matched our observations far better than the standard model ever did. Suddenly, this radical idea wasn't just theoretical speculation, it was starting to look like a genuine piece of the cosmic puzzle. The James Webb Telescope's discoveries are doing more than just challenging a few details. They're shaking the very foundations of cosmology. More and more experts are admitting what was once unthinkable: we don't fully understand the universe, and hidden forces or factors may be shaping reality in ways we've never seen or even imagined. Every new observation from Webb is a humbling reminder: scientific truths hold until nature proves otherwise. To grasp the impact of these findings, we need to journey back in time, back to an era when the cosmos was still shrouded in darkness. Before the first stars ignited, the universe was filled with dense clouds of neutral hydrogen, like a cosmic fog that absorbed and scattered ultraviolet light. Nothing could shine through. But then, as the first stars burst into life, they began to emit powerful radiation that ionized the surrounding gas, gradually clearing the fog and lighting up the universe. Astronomers call this monumental era reionization, and models have long suggested it began around 300 million years after the Big Bang. In theory, the earliest galaxies created small glowing bubbles in the hydrogen fog, tiny zones where light could finally break free. But beyond those bubbles, the universe remained cloaked in shadow. At least, that's what we thought. Then came Webb's jaw-dropping discovery, a galaxy known as Jade's jwst, shining brightly just 330 million years after the Big Bang. And it wasn't just glowing, it was flooding its surroundings with intense ultraviolet radiation, far more than scientists expected for such an early time. When astronomers analyzed its light, they found the unmistakable signature of Lyman alpha radiation, a telltale marker of energized hydrogen. This wasn't supposed to happen so soon. And now researchers are left wondering, did galaxies like this play a much bigger role in transforming the early universe than we ever imagined? But here's where things get really puzzling. This discovery doesn't just challenge a few details, it flat out contradicts what we thought we knew about the early universe. You see, according to current models, Lyman alpha radiation, that special ultraviolet light signature, shouldn't have been able to escape at that stage. The universe was still cloaked in thick neutral hydrogen gas, which should have absorbed or scattered that radiation. The fog wasn't supposed to clear until much later. Yet somehow, this galaxy's powerful light was shining through, reaching us from a time when the universe was just 330 million years old. The lead researcher, astronomer Joris Wittstock from the University of Cambridge, couldn't hide his astonishment. He summed it up bluntly, this was completely unexpected. Even though we're seeing this galaxy at a time when the universe was only 330 million years old, it shows a surprisingly clear, strong signature of Lyman alpha radiation. His colleague, co-author Kevin Heinlein, added, "We shouldn't have found a galaxy like this at all, and yet there it is. And the data clearly show that its UV radiation traveled farther than we ever thought possible." Their analysis revealed something staggering. The galaxy had carved out a bubble of ionized gas stretching 650,000 light-years in every direction. In other words, the surrounding hydrogen had already been cleared enough to let ultraviolet light escape, a feat that should have taken far longer according to everything we thought we knew. So what does this mean? Either cosmic reionization began earlier than scientists believed, or it happened much faster than our models predict. Could this be a clue that the universe has gone through cycles of rebirth, as Roger Penrose proposes? At the same time, the discovery hints at something equally intriguing. Maybe it wasn't just giant galaxies that reionized the cosmos. Perhaps smaller, less massive galaxies played a bigger role in lighting up the universe than we ever